let's talk about building a completely private AI factory. And no, we are not talking about buying some massive, expensive, power-hungry server rack. Instead, we're doing something way more interesting. We are building a sovereign AI ecosystem by resurrecting forgotten, supposedly obsolete hardware. We're going to push old tech to its absolute limits, string these incredibly constrained devices together, and orchestrate the whole thing with a strict, privacy-first mindset. Honestly, think about it for a second. Is the most powerful computer you own currently sitting in a drawer somewhere, just gathering dust? We're so conditioned to believe in e-waste and planned obsolescence. We think that after 3 or 4 years, our devices are just junk. But what if we completely rethink the potential of those discarded tablets, those old smartphones, and those underpowered little mini-computers? I absolutely love the hacker ethos captured here. Hardware doesn't expire when the manufacturer's support ends. That right there, that is the rebellious spirit driving the architecture we're exploring today. Just because a giant tech company stops pushing updates to a device, it doesn't mean the processor, the RAM, and the screen suddenly just stop working. They're fine. We just need to give them a brand new identity. Part 1. Resurrecting Legacy Screens. The 2016 Chewy Tablet. So to build the very first limb of our Frankenstein setup, we're taking a discarded 2016 Chewy Hi10 Plus tablet. It's a heavily constrained Intel Atom device with just 4 gigabytes of RAM. The manufacturer totally abandoned it, and honestly, standard Windows 10 completely chokes on it. So we ditch Windows entirely and install a streamlined Linux distribution, MX Linux, to bring it back from the dead. But getting this to work requires some serious cunning. The tablet's BIOS acts like a stubborn gatekeeper that flat-out ignores standard boot entries and only looks for specific Windows or Android paths. So the engineers pulled off a tactic known as BIOS identity theft. By literally moving the Linux boot files and renaming them to match the exact hard-coded Windows path, boot mgfw.efi, they tricked the tablet into booting Linux, all while the system genuinely believes it's booting Windows. And this brilliantly illustrates how hardware hacking is so often just a solved equation. The magic number here is 2.13. That's a calibration matrix coefficient. See, when you install Linux on a small, high-resolution tablet screen, you have to scale the visual interface up by about 150% just so you can actually read the text. But doing that entirely breaks the touch digitizer. You swipe your finger all the way across the screen, but the cursor only moves halfway. Frustrating, right? Well, by applying this exact mathematical coefficient of 2.13 right into the system rules, we perfectly realign the touch input with a scaled display. Boom. Hardware fixed with pure math. Part 2. The zombie surveillance camera, hacking the Galaxy S5. For our next scavenged component, we're converting an old Samsung Galaxy S5 into a permanent 24/7 IP security camera. It actually has a pretty great lens, but leaving a smartphone constantly plugged into a charger is a massive fire hazard. The battery will eventually swell up and explode, which is, definitely not part of the plan. So we have to perform some tactile hardware surgery. First, remove the battery completely. Next, solder a step-down buck converter directly to the battery pins so it delivers exactly 4.1 volts from a standard USB charger. But the S5 is pretty sneaky. It will refuse to boot if it doesn't sense a battery. So the magic trick here is adding a 10 kilo-ohm resistor right between the battery status indicator pin and the negative pin to fool the phone. Finally, you modify the boot files. Now the phone automatically powers on and starts streaming video the exact second you plug it into the wall. A totally perfect isolated camera. Part 3. The DualPi AI Brain. Separation of logic and labor. To really pull this entire factory off, we have to enforce a strict separation of logic and labor. On one side, we have a Raspberry Pi 4 running the Umbrel operating system. This acts as the decision agent. It hosts the Hermes interface, meaning it thinks, it makes decisions, and it manages your data. Then, on the other side, we have a Raspberry Pi 400 running the ultra-lightweight Diet Pi OS, acting purely as the execution engine. It runs all the heavy automation workflows using an app called N8N. If we actually tried to make a single low-power Pi do both the thinking and the heavy lifting, it would crash instantly. It's just too much. By separating the brain from the muscle, we totally maximize our constrained resources. Part 4. Extreme Optimization, running AI on 4 GB of RAM. Which brings us directly to the elephant in the room. How on earth do we manage to run modern, highly capable artificial intelligence locally on a Raspberry Pi 400 that only has 4 gigabytes of memory? Most commercial AI models require massive privacy-invasive cloud servers with absolute terabytes of VRAM. Well, the secret is quantization. This is essentially the process of compressing massive AI model weights. By using a highly optimized format called GGUF, we can take a surprisingly powerful open source model, like a Llama 3 or Phi 3 that has over 3 billion parameters, and squeeze the whole thing down so it uses only about 2.2 gigabytes of RAM. This is literally the absolute sweet spot for our local privacy-first setup. Because when you only have 4 gigabytes of memory to play with, every single megabyte is a battleground. We allocate roughly 2.2 gigs to the llama.cpp AI engine. Then, we strictly limit our NNN automation software to 800 megabytes using Docker constraints. That leaves exactly 1 gigabyte left over for the operating system, plus a vital safety margin to keep the entire system from crashing. It is a razor-thin balance for sure, but it works flawlessly. And to ensure things stay flawless, even under heavy loads, we deploy something called ZRAM. Normally, when a computer runs out of RAM, it writes the overflow data to your hard drive. In our case, that would be a super slow SD card or USB drive, which would instantly cause the Pi to freeze up. ZRAM acts like a turbocharger by compressing that overflow data directly within the RAM itself. Sure, it uses a tiny bit of CPU power to do the compression, but it keeps the whole system incredibly responsive. Part 5, your sovereign AI factory, tying it all together. All right, with our hacked tablet, our zombie camera, and our hyper-optimized dual Pi brains good to go, here is the exact flow of data in your new cohesive factory. Point 1. You fire off a command from anywhere in the world using Telegram. Point 2. That command travels completely securely through Tailscale. That's a mesh VPN that requires absolutely 0 open router ports, making it virtually hacker-proof. Point 3. The NN software on the Pi 400 receives your command and seamlessly orchestrates the task. Point 4. Your local quantized AI model steps in, executes the logic, and writes the code or text. And finally, point 5. The resulting output is permanently saved into an Obsidian Markdown vault right on your Umbrel server. Now you might be wondering, why Obsidian? Well, many folks use cloud solutions like Google's Notebook LM for their AI note-taking. And yes, it's very fluid, but it's also cloud-locked. Your data is being hosted by a massive tech giant, and you're arbitrarily limited to 50 sources. Obsidian, when paired with your local AI, represents total sovereignty. Your knowledge is stored in simple, future-proof, plain text markdown files right on your own physical hardware. These plain text files serve as the permanent institutional memory of your AI factory, entirely independent of any corporate cloud. So we have to end with this one final provocative question. Who really owns your AI's memory? If you're relying on the cloud, you are just renting your intelligence. But by resurrecting legacy tech, by pushing old tablets and low-power Raspberry Pis to their absolute limits through clever optimization and really precise orchestration, you reclaim your privacy. I highly encourage you to go look in your drawers,